So, I bet y'all been wondering where I've been. Or maybe you've already seen the posts explaining my disappearance from YouTube for well over a year now. Well, the truth is that I've not really had the time for it, with going through hardship after hardship in my personal life, along with a numerous number of projects being cancelled due to Dream's limitations. Sorry about that. To be honest, I'd rather not talk about that. But there is one project I have been working on in Dreams that you may have seen on my Twitter. But don't expect anything serious out of me from Dreams anymore. With that being said, let's move on to Unity. I'm going to assume you know how to use a computer at the very least. I tried to make a more detailed script, but it would just go on forever. First, let's get our assets and tools. We'll begin with Mixamo, as it provides a generic character for us to use and some decent animations for later. Navigate to mixamo.com and log in with an Adobe account, or sign up if you don't have one already. And once you're in the main menu for Mixamo, in the search bar, go ahead and type Locomotion Pack and click on the result. On the right side panel, we can see a download button. Click it. In the window appears on the left for file type. We want to choose FBX for Unity. Check the download button and save the zip to somewhere on your hard drive. And now that we have a starter character and some animations, we can get started with Unity. Head to the Unity download page and download the Unity Hub beta. You will also have to make a Unity account to use Unity, of course. And once you've installed Unity Hub, you'll need to install a version of Unity. Most of the new accessibility features are in Unity version 2021. The other versions listed on the installs page are for beta builds of Unity, as well as the long-term support older versions of Unity. We're going to be using the 2021 version specifically because it implements the visual scripting system directly into Unity, as well as a few other features that we may need. When installing the Unity 2021 version, be sure to install Visual Studio and the extra install options if you don't have it already, as at some point in the future you may need to write some code even though we have the visual scripting system. Start a new project under the Projects tab and select all templates. Choose 3D URP. The URP stands for Universal Render Pipeline, the standard low to medium graphics preset. HDRP has more high-def options, but that won't be required for this video. Go ahead and download the 3D URP template, and then name and create your project, and then wait for it to open. Now that we're in Unity finally, let's take a moment to get familiar with our environment. On the bottom of the screen is our folder explorer. It will let us explore all the assets in a project, including sounds, music, models, and textures, and any other kind of asset. It has a search bar on top and a navigation menu on the left. Next, to the top left of the screen is the toolbar. It has a lot of options that control your scene, your game, and Unity itself. To the left of your window is the hierarchy, which lists everything in the scene. You can see the scene in the scene view in the middle of your screen. And on the right of your screen is an inspector, which tells you all the information about things selected in every part of the editor. All of these windows can be rearranged, as well as tabs added and removed for editor features. There is one feature that I'd like us to install right now, as it will allow us to get easier input for our character. In the toolbar, click Window, then find Package Manager. In the window that appears, click the Packages button in the upper left corner and select Unity Registry. Then find the input system from the list and select it and install it. It's going to ask you to enable some code backends once you've installed it. Go ahead and click Yes and allow the editor to fully restart. Once the editor opens again, we are ready to import our character model and the animations. In the Assets library, create a folder called Models and a folder called Animations. Right-click the Models folder and select Show in Folder to open the Assets folder, and open the Mesh folder. Open the zip and drag the ybot.fbx file into the Mesh folder. In the Animation folder, select and drag all the other FBX files into the Animation folder. Now we have the assets in our Asset library back in Unity. Now if we look in our Asset library back in Unity, we can see the model and animations in our folders. One thing we need to do before we begin is we need to set our animations and our model to use the Unity animation rig. Select the YBot model, then in the inspector, select Rig. Change the animation type to humanoid and click Apply. This makes the model use Unity's humanoid rigging system, allowing many animations to transfer from one model to another. Do the same for the animation files we imported by first selecting them all, and additionally changing the avatar definition to Copy from Other Avatar. For the source, select YBot Avatar, then click Apply. Now let's actually add the character model to the scene and start developing everything we need for basic platforming. First, we need a way to contain our model and everything else for the player. To do this, we can right-click in the hierarchy to add a new object, create an empty object, and name it Player. Then drag the model on top of the object. This will parent the model to the empty object. With the scene window hovered and the player object selected, you can press F on your keyboard to focus on the player. We can move the camera by right-clicking it and dragging the mouse, using WASD and Q and E to move around the scene. And the scroll wheel is used to set the speed of our movement. In the inspector, let's add the player input module to the character. Select the player object, then click Add Component and search Player Input. Add the player input module, then click Create Actions and name it Player Input. This will open up the input manager. It lets you add multiple inputs for different actions for things that can happen in your game. By default, we get the movement, look, and fire option for player input. Let's click the plus button in the actions window to add a jump action. Now that we have the jump action, before we do anything, change the action type to value, and the control type to any. We do this because if we don't, we can't use it for on-hold and on-release events later in the program. Now we just need to map some buttons to it. Click on No Binding, and on the right, under Path, type space to add the spacebar as an input. If you want controllers to work, add a binding with the plus button on the jump action, then add your gamepad input, like button south. This would be the X button. Oh, it would be best if you assigned an input mapping, like keyboard and mouse, and gamepad for the gamepad input. If you don't do this, sometimes the input won't work, so it's best to always map your inputs to a control scheme. Make sure to save the asset before closing the window. Now that we have input, we can use it in visual scripting. First, we need to add the equivalent of a microchip to our character. Select it, then add a component, and search for Script Machine. Click New and name it Player Controller. Then click Edit Graph. Here, we're presented with a microchip-like menu that, as you can see, has nodes or gadgets that do things. By default, we get 2 event nodes. In Unity, they're known as units. The unit called Start activates a pulse as the game starts. The other that we see here, called Update, activates every frame. To the left of the window is a graph inspector and variables. Trigger inputs allow this graph to execute some code or logic, and the outputs let you execute code or logic in a different graph or microchip. Data inputs and outputs are basically input and output nodes, so we can use our microchip or graph, in this case, in another scripting graph. The variables are much like variables in Dreams, only there isn't a limit to the amount of variables. and we can have variables on all kinds of different levels. These levels include this specific graph, on the object itself, in the scene, app, or game level. Also, there's save variable. Now, let's take a look at the actual logic. Right-click the graph area and you will see a list of types of gadgets and a search bar too. At the top of the list is the object the graph is currently on, then the entire code base of the entire game and Unity engine. The rest of the selections are specific and I won't be going over all of it in this episode, as we want to focus on making this character move. We can find input logic under Events, Input. Here, there's 3 different units we want to focus on: Event Button, Event Float, and Event Vector 2. These all handle different types of input. Button is an on-off type signal, Float is a number signal, and Vector 2 is 2 number signals mapped to X and Y. The movement input is considered as a Vector 2, as it has input for left and right, up and down. Jump is a button type input, as it's a simple on-off switch. Our camera look is provided by Unity later, using a different tool that we can download using the package manager. For now, though, let's just focus on player movement. Oh, also, copy and paste works as well as undo and redo, and most shortcut commands that you'll find in other editor programs. With all of our input units, you can select the action under Input Action. Now, how do we actually use this input that we have here? Well, first off, what we want to achieve with this character controller is third-person movement. Well, to move our character, we need to add a few things to them first. To actually get movement later, let's add a character controller component to the player object. It may be confusing to add this character controller component when we have a graph for it, technically, that we're making that is called character controller. However, the character controller component adds a collider to our character and deals with angles, slopes, and step height limits, all of which we will need. Move the collider of the character by clicking and dragging the Y variable to 1.5, set radius to 0.3, and height to 1.5 to align the collider with the character. Also, we need to slightly adjust the model. Click on the Y-bot model and change the Y position to 0.65. Now, if the character has gravity, won't they fall to the void below them? Well, yes, but we can easily fix this. Right-click in the hierarchy and under 3D Object, select Cube. Name it Floor and select it. Let's resize it to be a floor. We can do this by changing the active gizmo to be a resizing gizmo. Let's do this by pressing the R key. And while we're at it, you can change to all of the available tool gizmos by pressing the QWERTY keys, QWERTY. Let's resize the cube to be the floor, and then we can readjust its position again by pressing the W key. Alright, this is starting to look a little bit like a Dreams scene already. Anyway, let's actually start doing some programming. Now, if you've been an avid user of Dreams, you can find some similarity with the tools and variables, and how the flow of logic can work. To move our character, we need to interact with the character controller component. To find it, search for character controller and select it. From here, we can delete the search and then search for functions in the character controller itself, and the function we want to find is called move. Search for move and then select it. Alright, well, here's some bad news for some of you. In order to get some smooth movement, we need to do some math. Fortunately, this scripting system makes it a little bit more simpler to understand. Since we got our input from an event, we need to separate our input from our physics math. We can do this by visualizing our input as a separate system from the movement system. This input system will give us a direction to apply our walking speed to. Furthermore, we can split up this system approach into several parts for our character controller: input, jumping, and player movement, just to name a few. First, let's think of what variables we will need for our systems. Well, for any kind of movement, we will probably need a set of numbers to represent how much we are moving in each direction. In Unity, we call this a vector 3. A Dreams equivalent would be the 3 number combined. Vector 3s are used in a lot of our logic, and even Dreams has them with the positional tag systems we have made in the past. So let's go ahead and add the vectors we will need. We're going to need a movement direction and a current velocity vector. The movement direction is a bit self-explanatory, and current velocity we need because to smooth damp our movement later. We also need a max speed float variable for movement, and a good starting value for this would be 5. We also need a camera variable that is a camera, so we can move the player relative to camera. For jumping, we need an isJumping boolean, jump power for how high we can jump, as well as jump gravity multiplier and fall gravity multiplier float variables for a smoother jump that we control. The value for the jump variables are 20, 1.5, and 1. At least this is a good starting point for fiddling around with later. We also need to know how long we can jump, so we need 2 more float variables, jump time and max jump time. I'd say a good max jump time is about 1/3 of a second, so 0.35 is good to start with. Now let's get the easiest thing to program out of the way first. We need to grab the main camera reference from our scene. Unity has a function to do this, but unfortunately it is a bit slow because it searches the entire scene for the camera. To get around this, we are going to cache the value of the camera at the very start of the game. Next to the start event, we are going to set our camera variable we made earlier. We can do this by alt-clicking and dragging the camera variable from our camera list, or we can search for the set camera variable. To get our camera reference, we can search for camera get main and connect it to the set camera unit. Now we can connect the start unit to the set camera unit. Now with this out of the way, let's get to the input logic. We'll start with jumping because it's easy. Grab one of the button event units we made earlier and make sure it's set to jump. And set the mode to on hold. Before we jump, we need to know if we are already currently jumping or if we can jump. And the first rule of if we can jump is, are we on the ground? And we can tell if we're on the ground from our character controller component. Go ahead and search for character controller is grounded and grab that. So if we are grounded, we're going to go ahead and jump. And when we jump, we need to clear our jump timer and then set is jumping to true. And if we're already currently jumping and we're still in the air, then we need to add to our jump time. And if we are currently over the jump timer, then we need to tell our character to stop jumping. So we need a few if units, 1 for if we're grounded, 1 for if we're currently jumping, and 1 if we're currently over our jump timer or not. These if units can get a little bit tricky to connect, so watch to follow along if you need to. Connect the isGrounded unit and the jump event to the first if unit. Then connect the false output of the first if unit to the second if unit. Click and drag on the isJumping variable to get it, and plug it into the second if unit. Connect the second if unit's true output to the third if statement's input. Go ahead and grab jump time and max jump time variables, and search for a unit called greater or equal. Plug jump time into A and max jump time into B. A is greater than or equal to B. Then plug that unit into the third if unit. Great! Now if jump time is greater or equal to max jump time, we need to set isJumping to false. So alt-click grab isJumping, connect the true output of the last if unit, click and drag the gray input nub, and search for boolean literal. We're going to leave it unticked, so it's a false value, so we are no longer jumping. Now, to actually jump, we need to grab a set jump time unit and connect the input to a float literal. This float literal is 0, so we are resetting our jump time. Now we need to set the isJumping variable. Go ahead and grab the set unit for that and set it to a boolean literal. Make sure the boolean is set to true. Now we need to add to our jump time. So grab a jump time variable and search for get delta time. This is the time it takes to process every frame, which adds up to seconds. We need to add them, so grab an add unit and connect them up. Then connect to the set jump time variable. We also need to connect the last if statement from earlier up to the set jump time input when it's false, because we still need to add to our jump time if we're currently trying to jump and we're in the air and we still have time left in our jump timer. Now grab another button event unit and set it to on release for jump. All we need to do here is set isJumping to false, so go ahead and set that to a unchecked boolean. Now we need to do the logic for movement, which involves a bit of math so we can move relative to the camera. First of all, we need to convert our vector2 input-output to a vector3. Grab our vector2 input event and change it to onHold and move. Use the vector2 output to make a vector2 get x and vector2 get y unit. Use the input trigger output to make a vector3 create x, y, z unit. Connect the x output to the x input and the y output to the z input. This is done because y is our up and down, and we want to use that as forward and backwards, and that's what z is. Now we need to rotate that movement to be relative to our camera using some quaternion magic. Grab the camera variable, then search for transform get Euler angle. Using the Euler angles, go ahead and get the Euler angles y value with vector3 get y, and then use the create vector3 trigger output to make a quaternion Euler unit. This unit is hard to understand, but it basically makes a rotation on whatever Euler angle axis we want, and since we only want to rotate our input on the y-axis, we are using the y Euler angle output that we just made. So plug the get y output into the y input of the quaternion Euler unit. Now to apply this rotation, make a multiply unit, then connect the output of the create vector unit and the Euler unit to the multiply unit. Finally, set our movement direction using the multiplied value. Now to make a stop when we stop moving, make another vector2 input event, only this time set it to onReleased. Now make a vector3 create node and connect it to the set movement direction node. Now there's only one last logic system before we can actually move it around and jump. Let's go ahead and focus on the update event. Earlier we talked about smooth movement. If we just applied our speed to our direction and added jumping and gravity, it wouldn't be very smooth or realistic. To overcome this, we will be using a special unit called Smooth Damp, specifically the vector3 Smooth Damp. We want the one that's in the middle of the search without the delta time or max speed. Go ahead and grab that unit and give it a once over. It needs a current direction, the desired direction, the velocity, and a smoothing time. The smoothing time can be finicky, but I find that 0.1 has the best results. To set up this unit right, let's get our needed values. To get the current direction we're heading, we can actually ask the character controller by searching for character controller get velocity. This represents the current direction our character controller is traveling in. To get our target direction, we can take the movement direction variable we have and our max speed variable, and then multiply them with a multiply unit. Then for our current velocity, we just need the current velocity variable we made earlier, and go ahead and plug in the current velocity into the current velocity input on the smooth damp. Now we need to grab the character controller move unit. If we plug in the output of this node now, it won't work very well for a few reasons. First of which is we need to multiply our output by delta time. Because the smooth damp function works every frame, we want to be moving 5 meters per second, not per frame. We are also going to need to save our current velocity output, as well as manipulate it a bit to add gravity in our jump speed. To do this, create a new vector3 xyz unit. This way we're only going to be affecting the y variable in the vector3. To actually set our y velocity, make an add unit and plug in the current velocity output from the damp unit and the new vector3 output. Then grab a set current velocity unit. Then go ahead and plug the output of the add unit into the set current velocity unit. The new vector is actually just our jump force. We can grab a select unit that selects between two variables depending on a boolean. This will either add our jump power or a float of 0 depending on the isJump variables. Go ahead and grab the variables you need and plug that in, as you can see. And now we need to add our modified gravity for a smooth jump. To do this, we need to set the add unit we placed earlier to add 3 inputs instead of just 2. Then grab a physics get gravity unit and a multiplier unit so we can use our multiplier variables. We're going to go ahead and select based on our isJumping variable again for the other multiplied slot for the other input of the multiplier unit. Only this time, if we're jumping, we need the jump multiplier, and if we aren't, we need the fall multiplier. Plug these all in, and now we can actually test this out. Great! Now the last thing I want to tackle for this video is the camera movement. Unity actually has a really nice tool that we can use that makes this pretty easy to use and fast to set up. This tool is called Cinemachine, and it allows for some pretty advanced camera tracking and setup. It can be used for games as well as animations. We need to add it to our project to use it. In the toolbar, then Package Manager, and again in the upper left if it says Packages and Project, go ahead and click this to change it to the Unity registry. Then find Cinemachine from the list, select it and download it, and install it. Wait for it to install, and now we can put on this last touch for this video. First, we need to add a Cinemachine camera to our scene. Right-click in the hierarchy, and under Cinemachine, click Free Look Camera. The settings in the inspector may be daunting at first, but over time you will come to understand them. Right now, it needs the target for it to follow and look at. We could select a player object itself, however, for more control, we can attach an empty game object to the player called Camera Target, and set this for the follow and look at target instead. To actually get the camera to respond to our input, we need to add a special component to our Free Look Camera object. Add a component called Cinemachine Input Provider. It's going to ask us for an input for the XY movement. Also, there's an input for Z, which is technically the roll. We only want the XY for now, so select it and find the player look input. Also, at the very bottom of the Cinemachine component is an Add Extension button. Click it and select Cinemachine Collider. This will make sure the camera doesn't clip through objects. A couple more things before we test this out. As you can see in the scene view, there are 3 red rings making a sphere. This sphere is the area in which the camera can travel, otherwise known as the orbits. You can adjust the heights and radius here, as well as the binding mode. The binding mode is how the camera tracks the object. We can change it here to world space so the camera is always fixated on the target unless we move the camera ourselves. There's plenty of settings here to fiddle with, so do get acquainted with it if you can. Finally, we can test out our character control. Now, of course, this system isn't without its issues. The dampening on the movement is kinda a little bit too slow on the startup, and jumping is kinda floaty and glitchy. All these issues can be fixed with some tweaking and fiddling, as well as using something called animation curves to replace the smooth damp function. We also need to implement animations, however, the Unity animation system can be a bit complex, so I'm going to be covering that in a future video. Some of the videos I'm planning on tackling will be animation, of course, better movement, better jumping, gameplay mechanics, and more. I hope you all enjoyed this video, and yes, I do have some new projects in the works, including something done in Dreams. If any of you have suggestions for videos, besides Dreams ones, of course, go ahead and leave a comment. Also, let me know if you're interested in seeing a never-before-seen Dreams video, where I try to teach my friend how to actually use Dreams, and I fail tremendously, and I end up making a game for him. Oh, and one last thing. The files for this video and all the further Unity videos will be provided on my Patreon page. This includes models and assets that I make for these videos for any modeling tutorials in the near future. I hope to see you all again really soon.